Hi everyone, my name is Wendell Edwards. Recently, a comment was left for me to look on trig ratios. So today's video would be about an introduction to trigonometric ratios. We will look on sine, cosine, and tangent to see what happens with it and why is it that we could use these to solve problems. I trust that you will watch to the end. Please subscribe, share, and you can always leave a comment when you wish. Thank you. In this video, we want to look at identifying the hypotenuse side of a right angle triangle, the opposite side, and the adjacent side. So let us start with a right angle triangle. Alright, so there we have a right angle triangle, and I put my right angle indicator here. So this tells me that it's a right angle triangle. The moment we have a right angle triangle, the angle, right angle here, this angle here, will help us to identify the longest side of any right angle triangle. The longest side of any right angle triangle is the angle across from the right angle. So if I should stand where the right angle is and imagine that I have a water hose and I spray the hose, the side that it sprays across to is the longest side. Not only that, this side is called the hypotenuse. And we don't want to mix up this side, the hypotenuse, with the other sides. So again, the hypotenuse is the longest side of a right angle triangle. And the reason why it is the longest side, because it is directly opposite to the biggest angle. Because the biggest angle of a right angle triangle is 90 degrees. Thus, it produces that longest side. Now, the other sides are adjacent side, also opposite side. So if you ask me which one of these sides are adjacent and which ones is actually the opposite side, then I will say to you, I don't know. Because in order for me to state the adjacent side or the opposite side, I need an angle. So the adjacent side and the opposite side, they're actually relative to an angle. So let us say I pick an angle here. Let me take back off this. If I pick an angle there, so if I pick this angle, then opposite to this angle would mean if I stand in this angle and spray a water hose, the side that it sprays across the touch is the opposite side to it. So in this case, right now, to this angle, this is the opposite side, because it's all the way across from it. And if I should erase this other side, you realize that the angle disappears, meaning there is no triangle anymore. Let me put it back. If I erase this, the triangle disappears. You know why? This is the adjacent side to the angle, because the adjacent side is the side that helps to form the angle apart from the hypotenuse. The other side that helps to form the angle, the side that is what we call margin, it is borrowing. So if we should move these, you realize that the border would have been removed and the angle disappears. So this is the adjacent side to this angle. But if you notice, if I should change the angle, so let's say I change the angle. What if I'm referring to this angle up here? If I'm referring to this angle up here, and if I should stand in this angle and spray a water hose across, likely it's going to touch this side. So this is the opposite side to this angle. Now, this would be the adjacent side then. Because apart from the hypotenuse side, the adjacent side helps to form the angle. So if I should erase this, then you realize that the triangle is gone. This is the adjacent side that helps to form the angle. So this is our adjacent. So again, the adjacent and the opposite sides are relative to the angle. However, the hypotenuse is the longest side, and it is the side that is opposite to the 90 degrees. So there you go, an introduction to right angle triangles, looking at the hypotenuse, the adjacent, and the opposite side. Thank you for watching.